Okay, kindly mute
Okay,
all.
kindly mute all.
Ajit Kumar.
Ajit Kumar.
Ajit Kumar.
Ajit Kumar.
Ajit Kumar.
Ajit Kumar.
Who is host?
Who is host?
Please kindly mute
Please
all.
kindly mute all.
Kindly mute all.
Kindly mute all.
Roll number
Roll
84,
number
Ajit
84,
Kumar.
Ajit Kumar.
J signal.
यस
नहीं म्यूट कीजिए अब अजीत कुमार।
मेरा तो म्यूट था पहले से।
आवाज बहुत कम आ रही है आपकी सर।
आवाज कम आ रहा है। नाउ इट इज ओके।
यस
यस ओके
ओके सर।
राइट राइट गुड गुड।
Volume is very slow, sir. Very slow volume.
Volume is very low. Think it is good. Okay, let it. Now everyone is facing same issue.
यस सर।
Yes, sir. Voice quality and volume is very low, sir.
Voice quality कम है. Yeah, let before starting class itself we rectify that. 1 second. Okay, now it is okay.
यस सर। साउंड
Okay, sir. Okay, sir.
Yes, sir.
यस सर
Are you able to hear me?
यस सर
यस सर।
Yes, sir. Yes, sir.
Are you able to hear me?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Now how is my voice?
My voice. Yes, sir.
यस सर मिल रहा है।
Yes, sir.
Okay, right. Right, kindly
Yes,
mute
sir.
all.
Kindly mute all.
Okay, in the last class, last session, same thing. Someone is not muted. Okay, in the last class, we have discussed about the general things like type of interlockings are available in railway system. Okay. Next, we have seen that what is the policy, which type of interlocking to be adapted at stations. Okay, we have seen this thing, and we have we have discussed about discussed also different systems, mechanical interlocking, electromechanical, electrical, and electronic interlocking. And in the last class, we have discussed the what is electronic interlocking system. Electronic interlocking system consists of what uh, consists of what we have discussed all these things. Okay. um, these we have all discussed in the last class. Now we are moving to discussion. Actually, what are softwares used in EA? What are the softwares used in EA? The softwares used in EA are two, that is executive software and application software. Okay. Uh, Softwares used in EA are executive software and application software. These two softwares, it will be loaded in the CPU of the system. It will be loaded in the CPU of the system. Okay. First, we'll see that what is application software and what is the executive software. Application software is the another form of interlocking logic. Another form of interlocking logic. So same signal interlocking logic software only we are calling as a application software. This application software is designed based on the interlocking requirement, and it will be designed based on the signal interlocking plan, route control chart. Yeah, based on this only, this application software will be loaded. The application software is specific to each station. Specific to each station, and normally this application software will be loaded at the stations, loaded at the station in the CPU, because this is the station specific. Because of that reason only, it will be loaded at the stations. It will be not loaded at the factory premise. It will be not loaded at the factory. It will be loaded at the site. Okay. Simple. Normally, what OEMs are doing, OEMs are who is executing the work. We're designing application software. In conventional circuits, conventional relay interlocking. For implementing the relay interlocking, we have electrical circuits are there, no? Like GNR, UNR, and NRR, RR, NRR, UCR, ASR, TSR. Like that same logic only we are using in the electronic interlocking system also. But whichever logic we are using in conventional relay interlocking, same logic only we are converting into the software. We are converting into the software, means every equation, every circuit we are converting into one equivalent circuit. Every circuit in conventional system, we are converting into a equivalent circuit. Okay. And that equivalent circuits binary form will be loaded into the system. Means simply every circuit we are converting into equivalent circuits, and all these circuits are finally converting into binary form, and that binary data will be loaded into the system. Okay. This is only the application software. Okay. Normally this application software will be loaded at the site. Now second software is the executive software. The executive software, generally, the executive software is the
Sir, what is RCC, sir?
route control chart. Route control chart or selection table is there, no? Selection table, TOC. Okay, that is the thing. Okay, normally in earlier in our conventional relay interlocking also, circuits we are designing based on this route control chart, control table, whatever it may be names, table, control table, selection table. In railway, some we are calling with different names. Okay, based on this only circuits are designed. No, in the same manner here, in electronic interlocking system also, the application software is designed based on these two things only: signal interlocking plan and route control chart. Okay, based on this one only, it will be designed. Okay, now we are moving to next thing, that is the executive software. Executive software is a common to all EAs for same manufacturer. Normally, it will be common to all EAs for the same manufacturer. Means unsolved systems, wherever it is installed, the executive software will be common in the system. So wherever that Vestas system is there. Vestas system is there. There they are using the common executive software. This executive software will be common to that particular system, common to that particular system. But the executive software is not common to all the EAs. Every EA having individual executive software, and it is common to only the particular that system. Only it is common. Means it is common because of that reason. Normally, executive software will be installed at the factories. Executive software will be installed at the factories. It will be installed at the factories, and while sending these CPU cards to the site itself, they will load this executive software in the CPUs and it will be sent to the site because it is a common. For that reason only, this will be loaded at the factory and it will be sent. Whereas this application software is a station specific. Because of that reason, application software will not be loaded in the CPUs and that will be loaded only at the sites. Okay, this is the executive software. This is the executive software. Okay, executive software is the common to all EAs for same manufacturer. And executive software, what is executive software? Means executive software is the system software. It is executive software is a system software. This software only performs all operations of EAs. All operations of EA, it will be done by the executive software. This executive software shall be defined. What executives of software will shall define what the system can do and how the various parts of the system operate together. That only the executive software means executive software will define the what system has to do and various parts of the system how to operate together. Okay, how the various parts of the system operate together. That is the only the executive software. Normally, this executive software shall include the startup and operational safety test, and that are the parts of processor continual assurance of the safety operations. Okay, normally, if you see the what are the functions of executive software, the executive software will do all these jobs. One, what it will do, it will monitor the all the vital and non-vital cards. It will monitor the vital inputs, vital output, non-vital input output cards. It is continuously monitoring these all these things, and it is processing the inputs. Means if there is any changes there in the vital input or non-vital inputs, the input will be processed. Then after processing these inputs, then this will execute the application software. This will execute the application software. Execute application software consists of what? Interlocking logic. Application software consists of interlocking logic. After processing these inputs, it will execute the application software. And once this application software has been executed, then this will application application software run होने के बाद then it will issue the command for driving the driving the outputs. The outputs may be field outputs or it may be panel outputs. It will be driven, and this executive software is continuously diagnosing. It is continuously internal diagnostics as well as external diagnostics also it is doing. Internal diagnostics means it is monitoring the health of the system. It is monitoring the health of the all the modules health. It is monitoring. So, and same time it is monitoring the external diagnostics also. Means interlock the external interlocking information also it is diagnosing. Suppose it will take the decision in case of any abnormalities there. In case of any abnormalities there in the system, then it will take the decisions, and this no, whether the decision may be either maybe the system may be suppose in case abnormalities notice होने के बाद this may be system may be set maybe restart or it may be shut down or other like that it will do the activity. And same time this is the it will do the communication management also. Suppose any communications are connected, all the communications also well is managed by the executive software. Simple executive software is the system software. This software will perform the all the operations of EI. All the operations of EI means simply this executive software simply monitoring the all the cards, vital input, vital output, non-vital input output cards monitoring. It will read the inputs from the inputs from vital and non-vital input card. It will run the application logic. Once the application logic has been run, then according to the application logic position, this will drive the outputs. It will drive the vital outputs, non-vital outputs. In turn, vital outputs or non-vital outputs are driven. According to that, suppose vital outputs are driven, field gas R will be operated. Non-vital outputs are driven, indications will be displayed on the thing. And same time, it is not only processing the thing and driving the command, it is doing the diagnostics also. After doing the diagnostics, suppose any system having any unsafe side is there, suppose abnormality is there in the system, it will take the decision to restart the system or to shut down the system. And this is monitoring the communication also, monitoring the communication. According to the communication status also, the decisions will be taken by the executive software. This executive software is same everywhere, doing same job. For that reason, it is common to all the years of particular make. Simply reading inputs, processing the logic, delivering the outputs, monitoring the system, and taking the decision. These are the only the this is the only the execute functions doing by the executive software. And because and this will be the common for that reason only, it will be loaded at the factory and it will be sent, because the executive software is common to all the EAs. For that reason, it will be loaded at the factory and it will be sent to you. And these are the differences between the application software and executive software. Normally, application software will be the common to all EAs for the same manufacturer. Okay. And executive software is common to all EAs for the same manufacturer. And application software will be ad specific, and it will be different for different stations, because interlocking arrangements at every station will be different. For that reason, every station having separate application software, application software. This is normally the executive software is installed at factories, and this will be installed at the site by the signal engineers. Okay. Normally, we know that what is executive software. Executive software performs the all operations of the EA, and it is only the logic developed as per the control table of specific station. This is only interlocking logic. Application software is interlocking logic. Okay. Normally, this executive software will not be loaded at it will be not modified at at the site. But this application software may be modified at a site. When we are doing when interlocking changes are there, during that time, application software can be modification is possible. And once we are doing a modification, only after conducting this test only, this logic will be loaded in the system and it will be commissioned. Normally, before if any modifications we have done in electronic interlocking system, we are doing the factory acceptance test and site acceptance test. Only after conducting this only, we are commissioning the station. Means here application logic modification possible at site. Okay. When there is a when we are changing in the yard, if you are changing any scheme, then we can go for application software modification is possible. Okay. This is the basic difference between application software and executive software. Okay. Normally, if you see that electronic interlocking system, the electronic interlocking system architecture, the architecture of electronic interlocking system for railway is designed to ensure the following system. The electronic interlocking system should be reliable. Reliability should be more high. Availability should be high, and easy. It should be easily maintainable, and it should be fail safe also. Now we'll see what is the definition of reliability. Reliability is defined as the ability of a system to perform a required function under stated conditions for a stated period of time, then it is called as a reliable. Suppose any equipment we can call reliable if it is performing a required functions under stated conditions for a stated period of time, then we can call that equipment as a reliable. We can call equipment as a reliable. Even our electronic interlocking system reliability should be high. To make the system reliability, the OEMs what they are doing, they are using the reliable components while designing the equipment. While designing the equipment, they are using all these reliable components to make the system more reliable. More reliable, they are making, and the system availability should be more. What is availability? Availability is defined as the ability of a system to perform its required function over period of time. That is called availability. Means the system should be readily available to deliver anything. Means it should be available for working. Then we can call the system as available. Means the ability of a system to perform its required function over a period of time. We are calling that is the definition of availability. It means the system should be readily available at any point of time. Okay, like that EA also should be always should be available to deliver the to deliver the things. Okay, then our EA equipment EA equipment also should be having more availability. More availability. Okay, suppose if it is unserviceable, it is not in the working mode, the availability is not there. So the availability should be more. Availability should be more, and the system should be easily maintainable. The system should be easily maintainable. Actually, maintainability is defined as the probability that a system or system elements can be repaired in a defined environment within a specific period of time. We can call any system is easily maintainable. Means if the system has gone under failure or failure, the system can be repaired in a within a specified period of time. We can say that system is a maintainable system. Maintainable. But if the system has failed to repair that system, if it is taking more time, we cannot call that system as a easily maintainable. Easily maintainable. And our EA system should be fail safe. EA system should be fail safe. What is fail safe means? It is the concept in which even when system fails, it fails on the safer side. Then only we can call the system as a fail safe. Means our system should be in the fail safe. Suppose even it fails also, it should be safer failure. Normally, if you see that our conventional relay interlocking, okay, every conventional relay interlocking itself is a fail-safe arrangement, because to control any gear or whatever gear, always we are using relays, and the relays also we are using the front contact, relay front contact. Suppose any suppose any failure is there, immediately the relay will drop, and we are not able to drive the gear. Very simple example is that track circuits. Suppose track circuits, if any lead wire has been cut, or immediately what will happen? Immediately the TR relay will drop. In case if the TR relay drops, the TPR relay will drop. If the TPR relay drop, immediately if signal has been taken up, the signal will go to on position. Like that, any failure, the failure will go to safer side. Even that EA system also, it should be fail safe. It should be fail safe. Okay, this EA system, it should be more reliable. Means more reliable means it should give the desired output. Desired output. Okay, under the stated condition within the stipulated time, and the equipment should be more. The equipment should be more available. Means availability should be high. Means it should be deliver the. It should deliver the things whenever required. Means system should be always will should be available, and easily maintainable. Even if it is any failures are there, the failures can be rectified in the less span of time. Within the defined environment, it should be rectified. Then only we can call the system as a maintainable. Or EA system should also be easily maintainable होना चाहिए. And even the system fails also, the system should go safer side failure only. Okay, here OEMs to implement this availability, the system to implement the system more availability, uh, to improve improve this availability. We adopted a one technique called standby. We adopted a technique called standby. Okay, here in the standby, what we are doing, we are keeping two systems. We are keeping the two systems. Not we are not keeping only single system. We are not keeping standalone system. We are going for the standby arrangement. We are going for the standby. Okay. In this, we having two types of standbys are available. Okay. One is the warm standby arrangement, and second one is the hot standby arrangement. This warm standby and hot standby arrangement, we are going that warm standby and hot standby arrangements are there to increase the availability of the system, and to make the to increase the availability of the system. The standbys are concept has been there used using standby concept. Yes, standby is of two types. One is the warm standby arrangement, and second one is the hot standby arrangement. Okay. Earlier, when systems are installed, we have gone for this warm standby arrangement. Okay, we have gone for the warm standby arrangement, and at present we are going for only hot standby type of systems only. We are going. And what is this warm standby and how in warm standby arrangement? How arrangement will be there means here. Here in warm standby systems, in warm standby arrangement, there are two systems will be there. Normally in EA systems, if two systems are there, we are calling as a system A and system B. We are calling as system A and system B. Okay. Sometimes we are calling a system 1, system 2 also, but generally we are calling system A and system B. If two systems are available in the warm standby, both the systems will not be power on. Both the systems will not be power on. Only one system only will be power on. Suppose here, if you see the diagram here, uh, here B system is in power off condition. Only A system only is there in the power on condition. A system is there only power on condition. This A system, it is reading the inputs. It is reading the inputs means it is reading the field inputs. It is reading the panel inputs. After reading these inputs, inputs will be processed by this EA, and if the after that the outputs will be delivered. The outputs will be delivered. Okay, this is the warm standby system. Here, second system will be off condition. Second system will be in power off condition. Okay. As long as this first system is in on and first system is delivering outputs, the second system will be there in the off condition. Second system will be off condition. And suppose in case during working time, if this system means whichever system is on, that system only delivering output. Now we can call that system as an online system here. The online system, if it is when it is working condition, if it is failed due to some any module has been faulty in the system, then in that case what will happen? The second system will be power on. The second system will be power on, and first system will be power off. The second system will be power on, and the first system will be power off. To make this arrangement, okay, to make this arrangement, some relays, some external circuits we are using. We are using some external circuits to make this arrangement. Suppose if the system is healthy, using the system condition, some relays we are energizing. Okay, we are energizing some relays based on the system, both the systems using this system health. If the system is healthy, some relays will be energized, and we are using some other relays to transfer this from one system to other system. We are using some relays, and here to do this transfers from A system to B system, that arrangement we can do manually or automatically also. It is possible that option. the changeover from A to B, B to A, that can be done manually or automatically. We can do this activity. Okay. For doing this transfer from A to B or B to A, we are using some system health connected relays and some external circuit. We are using external circuits, and using this relays condition, the changeover may take place manually or automatically. Normally, in wherever the warm standby system is installed, there we are keeping one rotary switch. The rotary switch having three positions. Okay, the rotary switch having three positions. One is the A position, and other one is B position, and one is the center position also will be there. Suppose if the rotary switch is there in the center position, if the rotary switch is in center position, suppose if A system is working, A system is in online, A system is power on. Suppose A system is working, then A system is delivering the output. Suppose in case A system, if there is any faults are there in A system, if any faults are there, okay, during that time, automatically a power will be disconnected to the A system, and the power will be connected to B system, and B system will on, and it will deliver the output. If the rotary switch is there in the center position, if the rotor switch is center position is the auto mode. Suppose if the rotor switch it is their auto mode, suppose in case a working system fails, immediately power will be disconnected to the working system, and power will be connected to the other system, and other system will switch on, and it will deliver the outputs after time delay. After time delay only, this will deliver the outputs. It will deliver the output if we are keeping in the center position. Suppose if the rotary switch is permanently kept in position number one, I mean in the A system, means always A system only will be there in the online. A system only will be power on. If it is working healthy, it will deliver the output. Otherwise, suppose if the system, even the power on after extending the power also, if there is any fault in the system cannot deliver any outputs. Okay, if it is there in that position. Suppose the rotor switch you are keeping in the B position, always the B system only power will be extended. If the B system is working normally, outputs will be delivered by the B. Suppose if the B system is failed, it will not deliver an output, and the transfer will not take to A system. Suppose here, in case any system fault is there, immediately you should if system is faulty is there, automatically to transfer from A to B or B to A, always we have to ensure that that should be kept in the auto mode. If we keeping the auto mode, if A fails, okay, then B will be power on, and output will be delivered. Suppose if B is working, suppose B is fail, automatically power will be extended to second system, and that is A system, power will be extended to A system, and output will be delivered by the A system if A system is functioning normally. If A system is functioning normally, this will take place. Okay. Now, if we keeping manually in one position, okay, always that system only will on. If the system is healthy, outputs will be delivered. If the system is failed, transfer will not take place, and that system only transfer will not take place. Okay, until the system is rectified, the outputs will not be delivered. Okay, this is the warm standby arrangement. Simply in warm standby system, only one system is power on, second system will be power off. The second system will power on only when the first system is failed. After ensuring the first system has been failed, there is some external circuits are there. Using that external circuits, the power will be switched on to second system, and power will be off to the first system, and the second system will starts the working, and after time delay, the output will be delivered. Here, normally in warm standby system, to take to take the changeover from A to B or B to A, this system will take minimum 3 minutes time. Minimum 3 minutes time it will take. Minimum 3 minutes time it will take. Okay. Why? Because if you see here, now the system A is in online. System A is in online. System B is power off. Means in the system B is in power off condition. Okay. Suppose system A only processing the logic and it is delivering the output. Means system A knows the input status, system knows the output status, and here some internal status also will be there. For writing the logic, we can use for writing this logic. Okay, we required input bits and output, means input field input gear status also required, and we required the output bit status, and we required some internal bits also, like in relay interlocking we having some internal circuits are there, no, like UCR, ASR, TSR, UIR, like that also, no. In even in the here interlocking also, this bits we are used, that bit status will change according to the inputs and outputs. According to the inputs and outputs, this status will be changing. The internal bit status it is used to change according to the interlocking. Suppose when you are pressing GN and UN, normally when you are pressing GN and UN, normally root initiation bit will be there, no? That root initiation bit status will become high. Once root initiation bit high होने के बाद that root initiation bit what it will do, that is NRR bit will do, it will try to operate the point. It will try to operate. For that, internally inside the system logic, the output bit will be energized. The output bit status will become high. Once the output bit status is high, then immediately CPU will send the command to the output card, and output will be the point output. The output means, I mean, point will be point output will be energized. Point output relay will be energized, and the point will be operated. Once the point is operated, again the input will come back to the system. Again the input status will change. After input status, like that, every point has been operated. Once the point has been all the points has been correctly set, again that inside the logic the root checking bit status also will become high, and subsequently root locking bit will become low, and finally signal clearance bit, HR bit, will pick up internally. Once this bit pick up in the CPU, the CPU will send the command to the output card, and output card will energize the relay. Like that it will happen. Means here in the system in the memory having the status of all the gears inputs, input status will available, output status is available, and internal bit status also available. Suppose in case this system has become faulty, okay, all the bits will go to a low position in zero, and second system will be power on. When the second system is power on, okay, second system to switch on this, normally any system to switch on and to come to the working mode, it will take some time. It will take some time. Well, even your computer is there. Computer, if you are pressing the power button, immediately it will not deliver out. It will deliver output after some time. During this is only booting time. In the booting time, what it will do? It will check all the things, whether software is there, integrity it will check, hardware integrity it will check. If all the everything is okay, then only it will come to working mode. Like that here also, system when power has been connected to the second system, second system to come to working mode, it will take the certain time. Okay, after system has coming to working mode, system to deliver the to come to the normal mode, again it will take some 120 seconds time, 120 to 130 seconds time it will take for delivering the outputs. Okay, why what will happen in why this 120-second time will take after the system working condition? Means very simple. In conventional system, if power supply has been disconnected to relay room and again power supply has been connected to the relay room, we know that in the relay room, okay, all the internal relays, all the internal relay status will be all the internal relays will be there in the drop condition, like ASR, TSRs, and TLSR, TRSR, like that. All the bits will become low. We know that suppose if it is ASR is down, TLSR, TRSRs are down, we know that on panel all the roots will be there in the locked condition. All the roots will be there in the locked condition. Again, there in conventional system, to make the system to make the system normal, what we are doing, we are applying the cancellations from a panel, or otherwise we are going to relay room and we are energizing the stick relays. We are energizing the stick relays and we are making the system normal. And then once system has become normal, only outputs able to deliver. Same manner here, if the second system once it if the system first time it is on, okay, and the system can able to read the input, you can able to read the inputs, okay, whatever input is there available outside, that input status may be high, but remaining this internal bits like ASR, TLSR, TRSR, these bits will be low, and output bits also will be there in the low condition. Because of this internal bits and output bits are in the low condition, and the roots will be there in the held up condition. Okay, roots will be there in the held up condition. Okay, here in electronic interlocking system, in application program, we are writing the logic. We are writing a logic. When the system is power on, automatically the signals cancellation will be initiated. Signals cancellations will be initiated. The signal cancellations will be initiated when conditions are fulfilled. Normally, we know that cancellations we can do only when train is not in the backlog portion. Train backlog portion में नहीं रहे तो ही आपको cancellation initiate हो जाएगा. Otherwise, backlog portion में रहे तो cancellation will not be initiated. Like that here also, one system एक बार working mode को आने के बाद, then it will start the applying the cancellation of all the signals. If the signal cancellations are initiated, then the root will be released after 120 seconds. The root will be released after 120 seconds. Means initially system to come into working mode, it may take 30 to 40 seconds, and it will vary from system to system. Okay, 30 to 40 seconds minimum time it will take. And once after coming to the working mode, first it will do the apply the cancellation. Once it after applying the cancellation, minimum it will take 120 seconds to come the system to normal working mode. Overall, it will take around the 160 seconds time to 160 seconds time to switch on the second system and to deliver the output. Means here almost you can take this 3 minutes, there will be a interruption. Minimum 3 minutes of interruption will be there for if the 3 minutes traffic interruption will be there in case of you are going for the warm standby arrangement. In case of warm standby arrangement, simply here warm standby, we are keeping two systems. One system is on, one system is power off. Okay, when working system is failed to switch on second system and the second system to deliver the outputs, it will take the minimum 3 minutes time, and it will depends upon the system also. Sometimes it will take up to 5 minutes also. Minimum it will take the 3 minutes interruption will be there. 3 minutes interruption will be there. This is the warm standby arrangement. Okay. Next, we're having one more arrangement, that is the hot standby arrangement. In the hot standby, what will happen? Here in the hot standby also, we're having two systems here. That is system A and system B. System A and system B, we're having two systems here. Here, both the systems are power on. In the hot standby arrangement, both the systems are power on. A system is power on, B system is power on. And A system is reading the inputs, B system also reading the inputs. B system also reading the inputs. Inputs from panel, inputs from field, it is reading by the both the systems. And both the systems are reading the inputs, and the outputs will be controlled by only one system. Outputs will be controlled by only one system. That is, which system is in online, that system only controlling the outputs. That system only controlling the output. Even warm standby also, output will be controlled by only one system, because there is only one system is on. Whichever system is on, that is only controlling the output. Here in the hot standby also case also, if both the systems are even in power on condition, the outputs will be controlled by only one system. Outputs will be controlled by one system. Here when systems are power on, when the systems, both the systems, even it is power on, initially the systems to come into the working mode, here also it will take around 3 minutes time. Initially, when both the systems are power on condition, सपोज आप दोनों सिस्टम को पावर सप्लाई निकाल के पावर सप्लाई कनेक्ट करने के बाद here also here the systems working में आने के लिए initially it will take the 3 minutes time. Initially it will take the 3 minutes time. Here what will happen when power supply has been given here, in the two systems, one system will become as a online, other system will become as a offline. Means here here if even the power supply connected power supply was connected to both the system at a time, here one system will become online, other system will become offline. Okay, any system, A system may be online, B system may be online, one of the system will become online, other system will be offline. Simply here whichever system is in online, that system only it is controlling the outputs, it is controlling the output. The first time, if it is take the first time it will take 3 minutes time to come into the working mode. Okay, suppose here subsequently, suppose if the system, if this once it has come to working mode, if it is there in the online, if it is there in the online, and second system will be there in the offline, we can call the second system offline only when actually here one more thing, between the online system and offline system there will be a communication link will be there. Through this communication link the data will be synchronizing between the online system and offline system. And online system and offline system, there will be a one communication link will be there in the hot standby arrangement. Whereas in the hot warm standby, there is no communication between the online system and offline system. Here, there is a communication between online system and offline system. Okay. Now, online system only it will read the inputs, it will process the data. After processing the data, it is synchronizing online system status with the offline system, and after synchronization the outputs used to deliver, means it is after processing it is synchronizing as well as it is delivering the outputs, it is delivering the outputs like that. In between we having the communication link. We can say the second system, if it only online, it is healthy and it is able to synchronize the data with the other system, only we can call the system as offline. Okay, suppose if the system is failure, we cannot call the system as a offline system, we can call the system as a quarantine system. Okay, now here offline system what it is doing, it is also reading the inputs, but it is not controlling any outputs, it is not controlling any outputs, and it is synchronizing the online system status, it is synchronizing the data on, it is synchronizing the status with the online system status. Online system, whatever bits are there, that is internal bits or output bit status is there. No, it is synchronizing the status. It is synchronizing the status. It is maintaining the status. Suppose in working condition, suppose A online and A is delivering output. Suppose in case A system is an A system, if any fault is there, in A system, if any fault is there, then immediately here B system will deliver the load without any time delay. Without any time delay, B system will deliver the load here. Why here there will be no traffic interruption here? Because second system also is there in the on condition, and the second system it is synchronizing the status with the online system. When it is when other system is working, this system is synchronizing the data with the other system. Because of that reason, immediately the system will deliver the outputs. Immediately the system will deliver the outputs. Okay, without any interruption. This is the hot standby arrangement. In hot standby arrangement, two systems are there. Both the systems are power on condition. If both the systems are power on condition and both the systems are independently reading the inputs, and here one system will become online and other system will become offline. The offline system will not deliver any output. Only online system only will deliver the outputs. And offline system, it is synchronizing is status of online system with the online system. Okay. And in case in working mode, if online system is failed, then immediately this system will deliver the output. This system will deliver the output. This is the standby arrangement. This is the standby arrangement. If you see the advantages and disadvantages of this warm standby and hot standby, normally uh, warm standby advantage, both the systems are not on at the same time. So probably the surge may not affect the standby system. This is the advantage of warm standby system. In warm standby system, only one system is on, one system is off. Suppose any surges are there in the power supply, that both the systems may not be affected. Only working system, only online system only will be affected here. This is the case for the warm standby system. Advantage of this warm standby system. And coming to the disadvantage, okay, there will be a downtime when our systems changeover take place, and the traffic interruption will be there about 3 to 5 minutes. Inevitable means here there is a traffic interruption also will be available here. Warm standby, because second system to switch on, it will take time. And one second disadvantage is that, okay, uh, we don't know the second system will able to take over or not, because only one system is power on, second system is power off condition. No, suppose earlier itself, our second system having any failure, we don't know whether second system is able to change over or not. Okay, that is the integrity of the offline system is not known. Okay, only suppose in case the first system fails, second system is unable to switch on. During that time only we can come to know that the second system also failed. For this reason only, during maintenance, during monthly inspections, we are changing the system from A to B and B to A, and we are ensuring that second system also working. And in case the first system fails, the second system it will be able to switch over to other system, like that we are ensuring. But we don't know the second system health, whether the second system is healthy or not, because second system don't have the power supply. This is the disadvantages of warm standby system. Okay, just we'll discuss this next. Hot standby system advantage, disadvantage. Second system advantage, what is here standby system advantage? This is the seamless changeover. Here changeover will be take seamless, or I cannot persist that. And there is no downtime here in case of hot standby system. Hot standby system, we don't, the changeover will take seamlessly, and there will be no traffic interruption will be there. Okay. And here disadvantage of this system means here both the systems are online, both the systems are always on, power on. During lightning, there is a chances that both the system may damage. Both the systems may damage. These are the drawbacks of this standby arrangement. Okay, we'll go for the break, and after a break, we'll continue our discussion. Okay. Okay, shall we start class?
Yes, sir.
Yes.
Yeah.
Yes, sir.
Yes, sir.
Okay, good.
Sir.
Simply, just so far you discussed standby arrangements, warm standby and hot standby arrangements. Okay, we have seen the differences between the warm standby and hot standby. Here, in the warm standby systems, power will be connected to only to the power will be connected to only one system. The second system will be off condition. Whereas in hot standby, both the systems are power on, power on. One system will become online and other system will become offline system. The differences between, we are discussing about the differences between the warm standby and hot standby systems. Okay, here warm standby system, whichever system is in on condition, that system only will deliver the outputs. Here hot standby, Online system will deliver output. Offline system will get synchronized with the online system. That will take place here in case of warm standby systems here, hot standby systems. Okay, here we know that warm standby system, there will be traffic will be interrupted. Traffic will be interrupted when working system fails and second system to switch on. Okay, it takes some time. It depends upon the time system to system also. Minimum 3 to 5 minutes time it will take interruption. But here when online system fails, offline system seamlessly take over the load and it will deliver the outputs. Here offline system simply it will be readily available. Okay, in case online system fails. If online system fails, immediately take over the load and it will deliver the loads. It will control. It will take the control and delivers the outputs. Okay. Uh, Normally during the changeover period, the system cannot take any commands and delivery outputs due to this there will be an interruption of traffic will be there. Here that is only. Here there will be no traffic interruption will be there. We know that. And coming to this, in Indian Railways, whether we should go for warm standby arrangement or hot standby arrangement. Okay, we have the policy. This has been issued in the 2012. Earlier, when systems are installed, okay, most of the systems installed in the warm standby configuration itself only. Only few stations only installed with the hot standby configuration. Okay, and in 2012, 2012 uh, studied the failures of both warm standby systems and hot standby system failures, and board has decided that 50% of the failures of EA are due to the resetting failures in warm standby system configuration of EA. Okay, EA may 50% failures are there because of that this failures due to resetting failures in warm standby system configuration only. And when it is resetting, time delay is taking. For that, in 2012 itself, board has decided that all the future installations will be only with the hot standby architecture only. Means here, to implement this changeover from A to B or B to A, we are using some external circuits, and most of the time these warm standby systems, this changeover failures are more, and every time changing over it is taking time. Okay, then board has decided that future installations all should be there in the hot standby system only, because if you are going for hot standby system, even the changeover takes place also, there will be no traffic interruption will be there. Whereas in warm standby systems, continuously failures are there, changeover failures are there. And for that reason, in 2012 itself decided that all the future installation should be there in the hot standby system only. And now phase by phase, what we are doing, we are converting these warm standby systems also into hot standby system. This is a policy. Suppose new stations all will come with the hot standby configuration only, but we are not going for the warm standby configuration, because warm standby configuration there will be traffic interruption will be there. Suppose, but initially when the systems are introduced, maybe that time they thought that and that too, that warm standby system is installed in the low traffic density, where traffic density is less. There only they have provided these warm standby systems, and but subsequently they have noticed that board has noticed that failures are more in the warm standby system. Change while doing the changeover, only problems are unnecessary failures are increasing. To avoid that one, they are recommended for a hot standby. But hot standby, if you are providing here, the problem is that common mode failures will be there, like surges. If surges coming into the systems may be both the system may affected and damaged also. For that only, we have to take the special precautions for these surges, to prevent the surges. Here, for that only, we are RDS has given one diagram for earthing and bonding diagram, how to make earthing and bonding diagram at the EA stations, and recommended for the this air termination system, and providing the SPDs at different locations at the entry of the power supply, and after that after protecting the supply, it should be connected to DCD IPS. Then IPS supply before connecting to the system. There also we are providing such protection devices, and in the EA systems we are providing a DC-DC converter. DC-DC converter output really before connecting to any sensitive equipment also we are providing the SPDs like that. By taking the care, the surges can be eliminated, or by providing the air termination system, that is on rods on the building, that lighting also can be, any physical damages are there on the building also, that can be eliminated like that. We have to do if you are going for the hot standby configuration. If you are going for a hot standby system, the system is more susceptible to these lightnings and side lightnings. You have to take the precautions to avoid this, and the future installations all will be there in the only in the hot standby configuration only. There will be no warm standby. Actually, the standby concept is there to increase the availability of the system. All the time, any one of the system is available, and interlocking used to run at the station. Okay, that is the idea behind the standby concept. Standby concept, that is that. Next thing is that to increase the fail safety of the systems, the OEMs are going for the concept called redundancy. Okay, redundancy. OEMs to increase this system to become fail safe, means if even failed also, it should be safer side. For that only, OEMs what they are doing, they are going for the concept called redundancy. The redundancy, it may be available in software, or redundancy it may be available in the hardware. Actually, EA system having the hardware components and software components are there. Here hardware we can see that input output cards and processor is there. Okay, and these are the hardware components. Coming to software, we having the application software and executive software is there. In the hardware part also, okay, they are using reliable components in designing of IO cards and CPU. But in the CPU, microprocessors are there. No, the microprocessors are not the fail-safe devices. And the microprocessor used in the CPU. Suppose if you see in the normally if you see one system here, normally one system one system, what is there here? You can see that system. These are the hardware parts like vital input relays, vital output cards, non-vital input cards, non-vital output cards, and CPU. These are the hardware. But here most of the place here vital input output, non-vital output in cards design, they are using reliable components, and okay, that is okay. These are almost working good. But in the CPU, we are using one processor. The processor is a not a fail-safe device. Processor is a not fail-safe device. Okay, and the processor having advantages like the processor size will be miniature size. It can do complex tasks, and the uh, task will be done in the less time only, and like that it will do. But microprocessor is a not fail safe device, and there is no well defined failures are there in the microprocessor. There are no well defined failures are there, and and that too, microprocessor is an electronic component. During life cycle, this may give parameters may change, and it give unsafe reactions. Suppose if it is giving unsafe reaction, the total system will become the unsafe, because all this in CPU, CPU work will be done by this processor only. If the processor is giving unsafe reaction, total system will become unsafe. Okay, and for that reason only, what they are doing here in CPU, in hardware, their OEMs, they are going for the redundant. Instead of one processor, they are using one more processor. Okay, the processors may be identical, or the processor may be different. Processor also may be used. Okay, that is a microprocessor. Why you want to go for microprocessor only redundant means the processors are not fail-safe devices. If the processor is not fail-safe device, the entire system will go unsafe reaction, because the decisions, the logic will, everything, the work of the CPU will be done by this processor. If processor is not working healthy, then the processor is not working safe, then it will give unsafe reactions. The system will go unsafe. To avoid that one, OEMs some OEMs what they are doing, they are going for redundant in the processor. And here in within the CPU, here in EA system we are using two softwares. One is the application software and the other one is the executive software. Other one is the executive software. Simply application software is designed based on the interlocking logic. Application software is designed based on the interlocking logic. But interlocking logic, we know that interlocking logic, what is there? We having the instructions, instructions like signal, GNR, UNR, like that. These only will be available in the application software. Whereas in the executive software, there will be a the executive software we having the decision making software. Executive software is the decision making software. And once software after designing, there are no well defined procedures for testing the software. Where there is no well defined procedures are for taking testing the software. And this is a decision making software. Executive software is software is a decision making software. Suppose if this software is giving any unsafe reactions, the total system will become the unsafe. Here, microprocessor, if it is giving unsafe reactions, the total system will go to the unsafe. And if the executive software also, if it is not functioning properly, and if he's giving unsafe reaction, the total system will go to unsafe. Okay, for that only OEMs what they are doing, they are going to make the system fail safe. They are going for redundancy in the hardware, they are going for redundancy for processor. In software, they are going for redundancy for the executive software, not for the application software. Application software is a simple or logic, nothing is there, but only executive software is the decision making software. They're only going for the redundant. Here redundancy we are using in the redundancy, it may be hardware redundancy or it may be a software redundancy. We are redundancy. What is the redundancy? Redundancy is defined as the provision of more physical resources than required to perform a function. Okay, that is called redundancy. Suppose हमको we require more physical resources than required. Suppose for working of the CPU, we require only one processor. Simply here we are providing one more processor only to make the system fail safe. To make the system safe. Suppose in case example, only one person is there, he is only taking a decision. Whatever he has taken decision, that is final. Suppose if two persons are there to take any decisions, suppose one person is one person decision, it is not agreed with the second person, then ultimately that decision will not be taken. Like that here also, by using the redundancy, if both the processors are safe only, the outputs will be delivered. Like that, that is the idea of this redundancy. Here redundancy is there only to make the system fail safe. The redundancy may be there in the hardware, the redundancy may be there in the software. In generally hardware also, the redundant, they are going for processor side because processor is a not fail safe device. And software also, executive software only, they are going for the redundant. Here the executive software may be written using different algorithms, or maybe using different algorithms may be used, or same algorithm also may be used. Like that it will be used. Instead of one, they are using two. Simply here hardware redundancy, hardware we having different system types are there. One out of one system, two out of two system, and we having the two out of three system. Like that redundancy is there in the hardware. In the hardware we having one out of one system, two out of two system, two out of three system. Redundancy in the hardware. In the here software also we having single software or dual software. It may be single, only one software may be used, or two different softwares also, two softwares. It may be identical or it may be different softwares also may be used. First, I will go to the hardware redundancy. Simply here hardware, it is a one out of one system. In one out of one system, wherever processors are used, the processor may be used in CPU. Sometimes the processor may be used in the IO cards also. Suppose wherever in one out of one system, one out of one system, wherever processor used, they will use only single processor. They will use the single processor only. Okay, whereas in wherever it is used, it will be used single processor only. In two out of two system, they are using two processors, and two out of three system, they are using three processors in the CPU. It may be in the CPU card. They are using three processors. Here in the it is the standalone system. Here we having the single system. In the single system, single processor is there. It is the one out of one system with standalone model. Okay, but anyhow, we are not now we are using in railways. We are not using standalone systems. We are going for the standby systems. Now we can see that here we're having two systems. That is a system A and system B, and each system wherever the processors we are using single processor. Here this is the warm standby arrangement. You can say that this is a warm standby arrangement. There is no communication between the online system and offline system. Okay, normally communication will be there between the online system and offline system. In hot standby, warm standby, there will be no communication. By seeing this itself, we can say that this is the warm standby arrangement. And here also we are using within the system we are using only one processor. System A we are using one processor. System B we are using one processor. Here we know that warm standby working in warm standby system. We know that only one system only online. That system only will delivering the outputs. The system only delivering output. Second system will be there in off condition, and second system will power on only when first working system is failed. After ensuring that first system is failed, the external circuits will transfer the power supply to the second system, and second system will come to the working mode and it will deliver the output. This is a one out of one system with the hard warm standby arrangement, and we can see this is the arrangement. Here there are two systems are there, A system and B system, and there is a communication between the A system and B system. This is like a hot standby arrangement. Normally communication will be there. Will be there between the two systems. It is there in the hot standby system only. And here both the systems may be reading the inputs. Both the systems may be reading the inputs, but outputs will be delivered by only one system. Suppose if A system is delivering output, B system will be there in the offline mode, and it is updating the data with the online mode. And suppose in case in working condition, if A system fails, the B system will it will control the outputs. It will control the output. This is the one out of one system with the one out of one with hot standby. Here one out of one system. Normally here also in each system there will be one application software. There will be one executive software. Here every system we are having one application, one executive software will be there. Suppose sometimes OEMs what they are doing, most of the OEMs what they are doing, if you are going for single processor, they are going for the uh, redundant in the software. They are going for the redundant software. They are maybe using two executive softwares. In one the normally this processor using one executive software, it will process the thing, and using a second software also it will process the thing, and they will compare these things and output will be delivered. Okay, like that. In Indian Railways, we're having one out of one systems also. Wherever one out of one system using, they are going for redundant in the executive software. They are going for redundant in the executive software. Okay, this is the one out of one system. This diagram is one out of one with warm standby, one out of one with the hot standby arrangement. Same, this can be represented like this also. Here we having in our S18 book, it is represented like this. This is EA1, EA2 means A, system B. System A reading input. System A inputs are reading connected to both A system as well as B system, and field inputs also connected to A system as well as B system, and there is no communication between the two systems. I mean, these systems are like a warm standby systems, and at a time we know that warm standby only one will be power on. Whichever system is power on, that system only will deliver the output. That system only will deliver the output. Okay, this is the warm standby arrangement. Okay, now this is the hot standby arrangement. You can see that same thing here. EA1, EA2. These are two systems are there, system 1 and system 2, system A, system B. The inputs from CCIP video, it will be connected to both A system as well as B system. And field inputs also will be connected to both A system as well as B system. And there is a communication link available between the two systems. Communication link available in two systems. And the outputs will be delivered by one system. Whichever system is online, the outputs will be delivered by the online system. And suppose in case online system fails, the outputs will be controlled by the second system. This is the arrangement here. This is arrangement here. Single processor with the hot standby system. Now we are moving to next 2 out of 2 architecture. Here only we having only one system, that is a standalone system. Inside the system, wherever the processor we are using, instead of one processor, we are using two processors, 2 out of 2. Here we are using two processors. The inputs will be read by the both the processors, processor 1 and processor 2, and both will process the thing. And after processing the thing, both will send their decision to the comparator, and comparator, after comparing only, the output will be delivered. In case of 2 out of 2 system, we are, instead of one processor, we are going for two processors. Okay, the processors maybe independently read the inputs, independently process the thing, and it will the decisions will be compared by one comparator, and if both are agreeing only, output will be delivered. This is the case of 2 out of 2 system. This is the like diagram for the 2 out of 2 system with the hard standby system. There are we having two systems, the system A, system B. That is the standby. Okay, there is no communication link here. This is the warm standby system. Warm standby system like arrangement. Here inside one system, we are using two processors. Processor 1 and processor 2. Even second system also having processor 1 and processor 2. Here we know the working of this system. Suppose here warm standby, we know that only one will be power on and second will be power off. Suppose here one power, which system is power on, that system only will processing. Here for processing, two processors are there, processor 1 and processor 2, independently process, and the output will be sent to the comparator. The comparator, if agrees only, the output will be delivered. Suppose here compare करने के बाद normal comparator will compare the two things. If agree, then only outputs will be delivered. Otherwise, outputs will not be delivered. Like that, it will be controlled in this system. Suppose during working condition, if this system fails, then external circuits are there. The external circuits will transfer the power supply. It will connect the power supply to second system, and when second system is second system is there, power on, we know that the first system will be power off, and the second system only reading the inputs. And here also there will be two processors for processing the data and for controlling the data, and outputs will be controlled by the system. This is the 2 out of 2 system with the warm standby architecture. Now we will see the arrangement in the 2 out of 2 with the hot standby system. Here two systems are there, system A and system B. We are having standby arrangement here, and there is a communication between the both the systems. It is a hot standby arrangement is there. And inside one system, we are using two processors. Wherever processor used, the processor may be used in, generally processors are using in CPU. Sometimes the processor may be using in input output cards also. Some processor it is used in the input output card also. Wherever they are using, they are doing similar. They are going for 2 out of 2. Suppose if the system is 2 out of 2, means everywhere they are using two processors. Like that here also, here it is a 2 out of 2 because two processors has been used here. And we know that working of this hard standby system. In the hard standby system, both the systems are in power on condition. This system and this system is power on condition. Both the systems are reading the inputs. And here if the both the systems power on also, one system will be online and other system will be there in the offline mode. The other system will be there in the offline mode. Okay, the offline system simply it is reading the inputs, and as well as it is connected to the online system, and it is synchronizing the online system data. The outputs are purely controlled by this online system. Once after reading these inputs, here for processing we are using two processors. दोनों process independently process करने के बाद output will be compared and output will be delivered. The processors may be identical or the processor may be different here. When they are going for 2 out of 2 architecture, the processor may be identical or the processor may be different one they are also using. Anyhow, here also for processing this thing here, there will be in the CPU of CPU, there will be one executive software will be there. There will be application software will be there. This application software also, it may be single application software they may use, or they may go for even for delivered software also they can use. Here also they can go for the one executive software, or it may be different executive software also may be used. Two executive software also may be used. Okay, most of the OEMs in which are EAs approved by the RDSO, here almost who are going for the redundancy in the processor, they are going for only single software only. They are single executive software only they are going. Okay, maybe systems are available with the uh, two out of two system with the diverse software systems also available. But in Indian Railways, we are using mostly four OEMs, four makes only majorly. But the system don't have this type of arrangements. Okay, right. This is the arrangement in the two out of two with the hard standby configuration. Same thing, it can be represented in other manner also. There are two CPUs are there. Okay, sorry. This is the standalone mode. Now you can see this is the thing here. This is A system and this is the B system. And same CCIP, the control com indication panel. We are connected to A system as well as B system. And inputs also connected to A system as well as B system. And within one system, we're having two processors, processor 1 and processor 2. That is only to make the system fails up. There here redundancy, they have gone for the in the processor only. This is the diagram. In another way of representation, the two out of two with the hot standby configuration. Simply the control com indication panel inputs has been connected to A system as well as B system. There are two systems are there, that is system A and system B, and there is a communication between the system A. Communication link is there for synchronizing the data between A system and B system. And within the system, we are using two processors, processor 1 and processor 2. Okay, this is a two out of two system with the two out of two with the hot standby system. And there is one more model is also available. That is the they can go for the two out of three. Here, two out of three system. Within one system, there will be three processors may be used. Three processors: processor one, processor two, processor three. Like that, it will be used. But here, to deliver any control action, the two processors has to agree for that thing. Any two processors. Okay, any two processor has to agree for the decision. Then only output will be delivered. Here in two out of two system, suppose two processors are there. Suppose one processor is not at all functioning, second processor is functioning, and the processor also not giving any unsafe reaction. During that time also, the output will not be delivered. The output will not be delivered in case of two out of two system. Okay, whereas here in two out of three system, one system it is not one processor it is not functioning, remaining two processors are functioning. If the two processors are agreeing for anything, the output will be delivered here. The output will be delivered here. That is the advantage of two out of three system. Whereas in two out of two system, if two processors are there, suppose one processor is working, one processor is not working also, output will not be delivered. Suppose one processor giving unsafe reactions, second processor is giving safe reactions also, the output will not be delivered. That is the problem with the two out of two system. But in two out of three system, if you are going once, if one processor working or not working also, remaining two processors are working, if both are agreeing, the output will be delivered. This is the case of two out of three systems. And this is the two out of three system with the two out of three system. Here we having standby arrangement, A system, B system, and this is the no communication. This is a warm standby arrangement. Here within one system, we are using three processors. The processors we are using here, the processors are you are using for taking the for doing the processing and comparing. Here, our majority processors decision on used for controlling the action. Controlling the action, it will be used here. This is a two out of three system, and this is a two out of three system with the hot standby arrangement. Two out of three system is the hot standby arrangement. Here I told that here system, every CPU, there will be a processor plus application software plus executive software. Okay, that OEMs, they can go for redundancy in the hardware, they can go for redundancy in the software. They are doing for redundancy in the software, they are going for redundancy in the hardware. Now I will show you here which systems in Indian Railways we are using majorly four systems. Okay, Okay, that is the systems we are using here. Ansaldo make Microlock 2 system is there, and Medha make MEA 633 system is there. Vestres having two models, that is the VLM 6, that is we are calling that one Mark 1. Vestres Mark 2 system is available, and Kyosan make K5 BMC system is available, and GE system GE make VHLC model is there, and AZA Praha one model is there, ESSA 11R. Here installations, most of the installations are there in these four only, on these five only. Five means here West is having two models, no. Number wise, if you take, I think so far Unsolved is having more number in Indian Railways. Maybe after that, these numbers are changing. Having Medha and Vestres, Mark 1, Kyosan, and Kyosan system, and Vestres Mark 2 also available here. If you see this Unsolved system, they are using the one out of one architecture. They are using the one out of one architecture, but here they are having the redundancy in the software. They are using the redundancy in the software. Means the inside the CPU, one processor only they are using, but they are going for diverse softwares. Two executive softwares will be used in the CPU. That is the Unsolved. In Medha, 2 out of 2 architecture means wherever the processor they are using the two processors, but they are using the there is no redundancy in the software. They are using single software there in Medha itself. And Vestres Mark 1, they are going for one out of one system with the diverse software. With the diverse software only they are going here. And Vestres Mark 2, they are going for the 2 out of 2 system with the single software. 2 out of 2 system with the single software. And Kyosan also 2 out of 2 system with the single software. Single software they are using. And the remaining models, these models are G and AZA Pro. Very less numbers only it is installed. I think G installed in more than 35 to 40 installations in India. That also in Central Railway, some parts it is installed, and some East Coast Railway they have installed. Okay, and this system will come only in the warm standby only. Remaining these systems, Medha, Vestres, Mark 1, Mark 2, and Kyosan, this will come in only in hard standby. There is no warm standby arrangement in the this system. But whereas in Unsolved, we having warm standby arrangement as well as hard standby arrangement. Initially, we are providing this warm standby arrangement, but nowadays we are not providing this warm standby arrangement in Unsolved also. We are going for only hard standby. Okay, and we are converting that warm standby systems also to hard standby system to get the advantages. Okay, and just AJDA Pro also it will come in the hot standby system. Mostly, if you observe here, wherever they are going, whichever system they have used one out of one architecture, there they are going for the redundancy in the software. Means they are using dual softwares in the system. Wherever they are going for the redundancy in the hardware, means 2 out of 2 system they are using. They are going for the single software. Means here redundancy it may be possible in both the hardware as well as software, but that systems are very complex systems. But whichever makes we are using, we don't have that type of arrangement here. Means redundancy in both hardware as well as software it is not available. Only it may be available for some models available, but that design is very complex. For that reason, maybe OEMs are not going for that redundancy in both hardware as well as software. And while doing this redundancy also, they can go for identical processor. Okay, that is easy. Identical processor also they can go, or otherwise they can go for that different processors also. Like that also it can be done. Okay, these are the systems available in Indian Railways. Means here to make the system more safer, I mean fail safe, that OEMs they are going for redundancy in software or redundancy in the hardware. And now this is a very basic block diagram of EA. You can now just so far we have discussed that with the help of single system only we have discussed that what are the components are available in EA. Now we can see the diagram here. This is the system here. This is a basic block diagram. Here this is the EA room or relay room, and this is a SM room. In SM room, for controlling this station, VDU is there and CCIP is there. Okay, VDU and CCIP is there. In the relay room, two systems are there. That is A system and B system. Means here we are going for the standby. We are going for the standby. Maybe within the system, according to make, it may be redundancy is there in the hardware, redundancy will be there in the software. It may be available in the systems. It will be available in the system. Okay, this is the thing here. Okay, it may be every system may be having redundancy in software, redundancy in the hardware. That is thing. Simply from field, the field gear status will be first terminated on the K-rack. From K-rack, the information will be transferred to the relay rack, and physically that relays will be energized in the relays. That means from field gear status will be field gear status or field gear driving relays will be kept in the relay rack. Kept in the relay rack. Okay, field gear status relays will be energized by the field gears, and field gear driving relays will be energized by the system. Here in the relay rack, we having field vital input relays and vital output relays are there now. The vital input relays will be energized based on the field condition. Based on the field condition only, this will be energized, and the vital output relays will be energized by the system. Energized by the system. Okay, energized by the system. In the relay rack, we are keeping the relays. Okay, the relays we are using interface between the field and the equipment. We are connecting field and the equipment. Here, the vital input relay status will read by the vital input cards. Okay, here also it will be different for system to system. Sometimes what we are doing, we are using separate cards for A system and B system. A system के लिए separate cards use कर रहे हैं, B system के लिए separate card we are using. For some systems, what we are doing, we are using common card for A system and B system. Okay, in this diagram, it is showing that common card. This vital input card, it is reading the inputs. After reading the inputs, the input status will be communicated to the A system as well as B system. The input status means here vital input card, after reading the vital input relay status, this will communicate to A system as well as B system. A system as well as B system. Yeah, if you see the diagram here, there is a communication is available between the A system and B system. This is the which type of arrangement is this? This is the hot standby type of arrangement. Here hot standby arrangement is there, and here we having two systems, system A and system B. Okay, this is standby, and the two hot standby arrangement is there. The input status is connected to both A system as well as B system. And in the SM room, control cum indication panel is there. The control cum indication panel status. The control cum indication panel status. Control cum indication panel, the non-vital input status will be connected to the non-vital input cards. The non-vital input cards, after reading this non-vital input status, that can be communicated to A system as well as B system. It can be communicated to A system as well as B system. And same time, the VDU is connected to A system as well as B system. It has been connected to A system as well as B system. Okay, right. Same thing here. In the same manner, the system outputs, A system outputs. The A system outputs are connected to vital outputs connected to vital output cards. B system outputs, vital outputs also connected to vital output card, and A system non-vital output cards, non-vital output status will be connected to, non-vital output cards. B system non-vital output cards also connected to B system outputs, non-vital outputs also connected to output cards, and A systems non-vital outputs, it may be connected to VDU, it may be connected to B system status also connected to VDU. Like that, if you see here, and this A system status will be connected to maintenance VDU. B system status will be connected to maintenance VDU, and A system status will be transmitted to data logger. B system status will be transmitted to data logger. If you see the diagram here, the A system is connected to all the modules. It may be connected to VDU. It will be connected to CCIP. Suppose it is connected to vital input cards. Okay, it is connected to vital output cards. It will be connected to non-vital output card. Like that, everything it will be connected. It will be connected to maintenance PC. It will be connected to data logger also. And in the same manner, B system also connected to all the modules. Here we know that in case of hot standby arrangement, only one system is on and second system will be sorry. In case of hot standby system, both the systems are on, and output will be controlled by only one system. Okay, either A system or B system. Suppose in case A system is in online condition, then A system in online condition, the A system reading the inputs from field, the reading inputs from panel, the reading inputs from VDU. Okay, and same time B system also reading inputs from field, B system also reading inputs from panel, B system also reading from the inputs from VDU. But the logic will be processed at, because online A system is in only online. This A only will process the logic, and A only will deliver the outputs. B will not deliver. Even now the B is there in the offline condition, and will never deliver the output if A is in online. Okay, it is simply synchronizing the data. Now maybe B system also reading inputs, but it will not deliver the outputs. It will not deliver the output. Simply, it is reading the inputs. B system only reading the inputs, but A system only read. It will read the inputs, process the data, and it will deliver the outputs. It will deliver the outputs. This only system only will doing the job. Here on in the SM room also we having CCAP and VDU. CCAP and VDU is there. On CCAP VDU also, at a time we can do operation from either CCAP or VDU, and simultaneously it is not possible to do operations from VDU. At a time it is not possible to do operations from CCAP and VDU. Always here two things in the SM room. If we have kept two things are there, no, for operation purpose. Either we can operate from VDU or we can operate from CCAP. Suppose here one will be there in the control mode. Okay, other one will be there. Other one will be the indication mode. Suppose if the whichever system is there in the control mode, from this system only it is possible to control entire system, and the entire system status will be represented in the system status will be indicated both on the control system as well as whichever system is the indication mode. That system it will be represented. It will be shown in the both the system, and there is some key will be there in the control cum indication panel, and there is some option is available in the video to change over from A to B and B to A. Suppose if the key is there in the panel side, now we can control will be done from the panel. Suppose if the key is there in the PC side, we can control from the PC. For that also there is a procedure is there. Suppose here, suppose if the control is with the CCIP, now the control if you want to transmit to the VDU, first we have to raise the request from VDU. We have to request the raise from VDU to control this, and after that we have to do some action. Means simply you have to turn this key towards the VDU side, then the control will go to the VDU, and now the system will become in the indication mode. Means here from VDU itself we can do all operations. Suppose when VDU is there in the control mode, suppose if you want to transfer this to again to control to the panel mode, again here what we have to do, we have to operate your panel bar PC key toward the panel, and we have to acknowledge from the video, then again the control action will take place. Means here we can control the station either video, either from panel or video. We have to do that. Suppose here now the control is with the CCIP, and now the system A is in online. Suppose to take up in this case, normally the field input status will be read by A system as well as B system. Okay, when we are operating on the panel status will be communicated to A and B. The panel status will be communicated to A and B.
Now, because of A is online, this will process the thing, and after processing this, if conditions are all okay, this will give the control signal to the output cards. Then output cards, if conditions are okay, it will energize the. Suppose conditions are okay, then CPU will transmit the control signal to output card. Output card, it may control the output relays. If the output relays are controlled according to the output relays condition, the field gears will be operated. Once the field gears are operated, the field gear status will be again represented back in the form of inputs, and the input status again will be connected to both the A system as well as B system. Then again, this system will process the logic, and generally this will represent the yard status both in VDU as well as CCIP, both the VDU and the CCIP. Like that, this is the normal working of EA system, normal working of system. Suppose if the control is with the VDU, if the control is the VDU, now simply if system A is in online, system A is reading field as well as system A is connected to VDU. Suppose if you are doing any operations from VDU, the status of inputs will be go to A system as well as B system. And if it is A is in online, then A system will process the thing, and A system will deliver the field outputs, and it will deliver the non-vital outputs also. Then this status will be updated in both VDU as well as CCIP. It will be updated in both CCIP and VDU. Okay, means here indication, even the system is there in the indication mode. Indication mode operation cannot be possible here, but the status will be shown in the CCIP also. The status also shown in the CCIP also. This is the basic block diagram of EM. Normally, while discussing that policy, I told that we have two types of arrangement: centralized configuration, centralized architecture, and distributed architecture. Okay. What is mean by centralized architecture means, in the centralized architecture, what we are doing, we are keeping all the EA equipment at one place, and all the field gears we are connecting to the system, and we are connecting to this is a centralized architecture. In the centralized configuration architecture, all the EA equipment we are keeping at one place, and all the gear status will be connected to here, and the interlocking activity will run at this place only. This is the centralized configuration, and we are having one more arrangement, that is the distributed configuration. In distributed configuration, what we are doing, the EA equipments we are keeping at different locations in the yard. We are keeping at the different locations in the yard. Okay, that depends on how many locations we have to keep. That depends upon the yard. Okay, we can go for any number of cabins here. Any number of cabins here. Here in if you are going for distributed configurations, we're having some advantages. Okay, and we're having some advantages here. Suppose normally, according to our policy, more than 50 routes are there. We have to go for the distributed type of configuration. While going for distributed type of configuration, we have to select these number of cabins or cabins according to the yard condition. According to yard condition, we can go, and there is no policy that how many cabins we have to go. How many cabins are how many locations we have to go. There is no policy for this, and only that depends upon the yard condition. We can go for these things. Now here in distributed architecture configuration, suppose here the equipment may be kept at a different locations in the yard. The equipment kept at the different locations in the yard, but here, but entire interlocking will be done at only one place. Even though equipment we are placing at different locations in the yard, but that interlocking will be processed at one place. Interlocking will be processed at one place. The interlocking, wherever it is processed, there we are keeping one. We are keeping one equipment called CAU, or otherwise, if there is no equipment named as CAU, the EA equipment available that location itself will work like a CAU. CAU means central interlocking unit. Central interlocking unit. The equipment kept at different locations in the yard now, that will work like a object controller. That will work like a object controller. What is object controller? Object controller is a equipment. Simply, it will read the all the field gears, all the field gears available there, and the field gear information will be sent to the central interlocking unit. Central interlocking unit. It will be sent to the central interlocking unit, and at the central interlocking unit only, the decision will be taken. The central interlocking unit, wherever central interlocking unit is, central interlocking unit is available, that only will take the that only will process the logic, and that will only will deliver the commands. That will only deliver the commands. Okay, this object controller is object means NDCA means. So NDCA mean whatever equipment is there, it will work like a object controller. Simply object controller, what it will do, it will read the field gear information. It will send the information to CAU. Okay, once CAU, after processing the interlocking, and the CAU, if you send the control signal, the object controller will drive the outputs. It will drive the outputs, and in turn the field gears will be driven. Okay, like this. This is object controller will work like a slave unit of CAU, slave unit of CAU. Okay, slave unit of CAU. Okay, now if you see, I will see you one diagram easily. If you see here, in the yard we're having 4 cabins. This is cabin A is there, cabin B, cabin C, cabin D is there, and SM room is there. Here, okay, I will go to one more diagram. Okay, suppose here we're having cabin A, cabin B, cabin C, cabin D is there. Now here, out of these cabins, one cabin in one cabin, there may be a equipment name called CAU, Central Interlocking Unit. If you see in the MEDA, they're having one separate module is the Central Interlocking Unit. Okay, if you see the remaining systems, Ansaldo and Vestres Mark 1, Mark 2, and Kyosan. In Kyosan system also, we're having one equipment is there called Logic Subrack. Logic Subrack is there. The Logic Subrack, it will work like a Central Interlocking Unit. In case of MEDA, there is a name sub equipment name called CAU is available. This will only process the interlocking. And in the Kyosan, there is one logic subrack is there. That logic subrack also will work like a CAU. But whereas in Vestres Mark 1, Mark 2, Ansaldo, there is no equipment name called CAU, but that equipment kept at that location will work like a CAU. That work like a CAU. Central, the equipment work placed at this cabin will work like a CAU. Okay, this will only process the logic. This only process the logic. Suppose if you see here, means here the interlocking will be processed at the D cabin. For processing the interlocking, there may be equipment name called may be available. Central interlocking unit may be equipment available. If separate central interlocking unit is available, here in the D cabin also there may be some field gears. वो फील्ड गियर्स को रीड करने के लिए, फील्ड गियर्स को ड्राइव करने के लिए, there may be one OC also available in the cabin. There may be one OC also available in this cabin. Okay, CAU only process the logic, and OC, what it will do, only it will read the thing and it will send to the CAU. It will send the information to CAU. Okay, like that it may be available. Suppose if there if you see that in case of microlock and Vestes Mark 1, Mark 2, there is no equipment called CAU and object controller. The equipment at D cabin, it will work like a CAU and OC. The equipment will work like a CAU and OC, because here this only will process the thing, and here locally also there may be some gears are available. This will work like a CAU plus OC in case of this Ansaldo and Vestas Mark 1 and Mark 2. Okay, in the D cabin. Suppose if you take this other systems, we having other systems where we having CAU one equipment, and there will be one OC is available in the D cabin. Okay, if you see that ND cabins, in ND cabins, okay, in ND cabins normally there is one object controller equipment will be there. In case of MEDA and in case of Kyosan, there is a object controller equipment is there. Simply this object controller will read all the field gears information, and after reading the field gear information, that information will be sent to the central interlocking unit. In case of MEDA, this will happen. Suppose other systems, Ansaldo and Microlock, this equipment, whatever equipment placed in the cabin, this equipment will work like a OC. This equipment will work like a OC. That equipment will work like a OC. Normally, OC, what it will do? OC reading the inputs and sending the status to this central interlocking unit, or whichever equipment we are treating as a central interlocking unit, that will send to the central interlocking unit, and based on the central interlocking unit, the outputs will be controlled. Okay, outputs will be controlled. Here, this will happen like this. Okay, in case of Ansaldo, there is no equipment name called OC, but equipment which are kept at this location, that will work like a OC. What OC will do? Simply is a like a IO gatherer, collecting IO, sending to CAU, process करने के बाद outputs will be controlled. That is the job that will be done by the CAU. But here, in case of Ansaldo and Vestas systems, the equipment kept at D cabin, it will work like a CAU, and it will work like a OC. CAU and work like a OC. Okay, here in distributed configuration, in one cabin, there is a CAU equipment will be there. That CAU equipment will be connected to all the cabins. All the cabins means all the interlocking gear status information coming to this location, and interlocking will be processed at this place, and from this only the control signals will be given to respective cabins, and respective cabin OC will drive the field gears. Okay, this is the distributed type of configuration. Suppose if you are going for distributed type of configuration, we are if you are going,
सर एक क्वेरी है।
Hmm.
ये जो ओसी में दो सीपीयू दिखाया, सीपीयू
Yeah.
ए और सीपीयू बी, ये हॉट स्टैंड में है क्या? हॉट स्टैंड पे है?
Right. This is the thing here. There may be two things also will be available in each cabin. Also, there will be two things available. Hot standby there also will be available. There also maybe hot standby is available. Everywhere hot standby is be available. In the OC also maybe hot standby is available. Okay, here system,
Yes,
here system, hot standby here also available. Okay, in cabin
Yes,
also. Here also suppose one is not working, other system will take care. Okay, like that
Yes, sir.
processing everywhere is there. Or standby arrangement will be there at every location. Okay,
Yes, sir.
right,
Yes.
right. Good. Next, this is object distributed configuration. If you are going for distributed configuration, what is advantage here? The cabin to cabin connection, we can go with the OFC. The cabin to cabin, we can go with the OFC, and cabin to cabin, we are sending only information, digital data only. That also we are sending to OFC, and here while connecting this, the data can be connected in ring fashion. The data can be connected in the ring fashion, and we can connect multiple rings like this, and there will be always data will be available here. Data will be available with the system. Suppose here the cabin, treat that this was the north cabin, this is a central cabin, and this is a south cabin, and north to central cabin connection, like the direct connection is available, or otherwise from north cabin to south cabin, and south cabin to central cabin also communication is available. Here suppose in between there is a OFC having problem, the data can be sent to through this path also, it can be reach the central cabin. Suppose in case this also failed, north cabin to south cabin also failed, there is one more optical fiber cable available. Through this path directly data can be sent, or otherwise the data can be sent in the other path also. Like that, there is a redundancy is there in the redundancy is there in the communication. If you are going for distributed type of configuration, redundancy in the communication is available, and field gears and the cabin, the distance will be very less. Okay, field gear and the object controller, the distance will be very less, and the field gears are driving from that location only. Normally, we know that if the length is distance will between the controlling point and the control gears. If it is less, the voltage droppages will be very less. Okay, and here if you are going for object controller, we're having some advantage like separate cables also may be laid to the gear, separate gear, and suppose that will be very easy for maintenance. Like suppose any cable has become defective, or otherwise we can if spare cable, then the restoration it will be easy. Suppose like a conventional system, what we are doing, we are laying 30 core cable from relay room to one centralized location. From there we are laying separate cables, like that we are doing. But here individually cables you can lay from directly from object controller to the equipment. Like that we can having some advantage. And one more thing, we can eliminate here copper cable. If you are going for distributed type of configuration, copper cable can be eliminate, we can eliminate the copper cable usage. And only function wise cable you can lay, and the cable length also it will be very less. Okay, we know that copper cable having many disadvantages, like induced voltages. Induced voltages will come. Suppose length is there, the induced voltages also will become more, and it will create the problem. And copper cable cost. And in case the copper cable cut also, in case of centralized or conventional system, the gear information will not be sent to the interlocking place, and that will be that interlocking cannot be completed. But whereas here cabin to cabin the communication is OFC, and OFC having redundancies in communication, that in other path also data can be sent. Like that we're having some advantage if you are going for the distributed type of configuration. If you are going for the distributed type of configuration, we are having the thing here, we're having the advantages here. Okay. What is central interlocking unit? Central interlocking unit is a processor based interlocking system which holds the firmware. Firmware means executive software, and the station's specific application logic for interlocking. It processes the station specific application logic based on the vital inputs received from the field and non-vital commands received from the panel, and it will process the thing and generates the vital outputs to control the field gates, and it will generate the non-vital outputs to show the status of the yard on VDU and the CCAP. Okay, the CPU may be connected to object controllers to control the field gates in distributed interlocking type environment. Okay, here what is object controller? Object controller is a processor based system. Object controller shall be normally placed in the field locations. Suppose I told already, in some systems we don't have any some equipment named as object controller, but that equipment will work like a OC. What OC will do, like that OC will do. Okay, the location of the OC shall be selected. Strategically, it will be selected to reduce the requirement of signaling cables and interface relays. Normally, OC, how many OCs are required in the yard and where to place the location, it will be strategically selected to reduce the requirement of signaling cables and interface relays. And the OC shall work like a slave unit of CPU. Means OC cannot take any decisions. OC will depends upon the CAU. OC will depends upon the CAU. Okay, and object controller is a mediary system between the CPU and field gates. Okay, and object control will communicate with CPU to get the commands to drive the field gears directly, and send the status of the field gear back to CPU. And even the field gear status, once it has been driven, the status also will be sent back to the system. Normally the communication between the object controller and OC shall be on redundant and duplicate OFC and redundant duplicate basis we are sending. In case the communication failure between the CPU and OC, all the outputs of that OC shall be brought to the safe set. Suppose in case the communication fault is there between the OC and CAU, then the outputs of the OC shall go to the safe state. And if there any fault is there in the that particular OC, and all the outputs of that OC will be withdrawn, and any OC fails, and it is independent, that is pertaining independent from other OC. Suppose the total entire system will not affected. Suppose if any OC is faulty, that particular OC only will be affected. Other OCs will not be affected if you are going for the distributed type of arrangement. If you're going for the distributed type of arrangement, okay, these are the things available here. And lastly, we'll discuss some advantages of EA. Okay, what are the advantages of EA? Okay, these are the advantages of EA. Okay, what is the advantages of EA? Normally, EA system requires the less number of relays. It requires a less number of relays. Okay, anyhow, we'll do one thing. We'll discuss these advantages tomorrow. Okay, we'll close the session here. If you're having any doubts on this distributed interlocking, centralized interlocking, and standby arrangement and redundancy, you can ask me. We'll after this we'll close the session here. Okay, you have any doubts on this?
No, sir.
Okay.
Shall we get notes?
सर
Yeah.
सर वो पीपीटी चाहिए सर.
Okay, we'll share you. Already it is available in. Okay, we'll share you. PPT available in net also.
Okay, sir. Thanks.
Okay,
सर
thank
इसका
you.
प्रेजेंटेशन दे दीजिए.
Sure, we'll give.
प्रेजेंटेशन दे दीजिए सर ग्रुप में.
Sure, we'll give. Okay.
Thanks.
Okay, thank you. We'll close the session.
Thank you.
Okay, thank you, sir.
Thank you.
Thank you, sir.